Welcome to the Keep It Simple Astronomy channel. Finally, a good night for you and me. And exciting news today. Well, first let me tell you something, it's very important. Today I had, those days that you wake up and life gave you a huge problem to solve, bam, in the face. I had to solve something all the day. And then at night, I had loads of nights with dust or wind or whatever, or clouds. And today I was tired and I came outside and I saw at the evening, I saw the sky clear, almost no wind. And I said, this is my opportunity to calm down because I was too stressful during the day. This is important because many people can relate with this. Stress over the day, whatever the reason, and then at night, astronomy calm down and connect us to the universe and gave us a good vibe. So I said, no, I will place my 8-inch Dobsonian because I was tired. I place only the 8-inch Dobsonian, which is super easy to place, And then I thought I have to share today because the moon will be brighter and brighter, and then the forecast is bad here for tomorrow. And I said I have to share. It's my opportunity to make the live stream, to share my exciting news for you finally. And I said I will take a shower and then I will do the live stream and we'll be fresh again. And astronomy is very nice for that. I'm sure some of you may identify with this. Hello everybody. Hello Ray. It's great. Astronomy, it's great for relaxation. Yes, I start with this because for me it's the most important. Not the things I'm going to tell you are very nice, but the juice of astronomy is this: a bad day, one of the worst days of this year for me. I solved things, and now I will calm down with astronomy and with you, all of you. And thank you for being here. Ray is a very kind person that was in a live stream with me. Hello, Edward. How are you? Hello, Quasar. Good evening. Carlos. Hola, Carlos. Good night. Okay. So, the news. I've been testing, not too much because of the weather, of course, but I've been testing a very, very, very nice feature I discovered. This is for beginners. This is not for beginners, but for beginners, if you are watching me now or in the replay, please pay attention to this. It's a thing that not many people, only a few people talk about this, and usually people that know a lot of cameras and things like that, much more than me. But through that knowledge of those few people, I start thinking and I realize something. I discover something that fits very well, especially with an 8-inch Dobsonian. I tried already with a 12-inch, but especially with the 8-inch Dobsonian. And this is so powerful because I spent, not today, I had spent before $50 to do this. And $50, that's worth a lot. Not in that moment. I will show you what I'm using. Hello, Daniela. Welcome. Daniela is from Portugal also. Delaware. From Delaware. Burnham, 11. Oh, my story, Edward. I love Yay. My story is being told video after video, and today it's a part of it. I will show you a tool that I bought almost a month, a year ago, and that's a tool that when I bought, it was to test. It was cheap, $50, but then I realized I will not use it. But I kept it. Maybe I can use it. It's this. I will show you. I have the 8-inch outside already. I will just tell you what is it, because it's very important, and then I go outside to you for you to see it in action. This is, as I said, this is not so much for beginners, but pay attention, because this is an easy thing to do, because it has a lot of knowledge that it's a bit more. Okay, this is a focal reducer. It was not innocent. It was intentional. The poll I threw to the chat, because I wanted to have a feeling about what you use. And by the way, let me see the results of the poll by now. 73. I asked, do you ever use a focal reducer? 73% says no. So clearly, most of you that are now live didn't use it. Well, I bought this 2-inch focal reducer. It's a cheap focal reducer from PS Optics. There are cheaper ones. There are other brands that about $30 from Amazon or something. You can buy a cheaper focal reducer, but I from the inexpensive range, I like to buy. This brand is good. Telescope Service is TS. It's from Germany. I trust them, and I bought to Astra Shop. This is the GSO, in my opinion. Loads of focal reducers are from GSO brand. This basically you attach to the camera and increase the field of view of the camera, shorten the focal length of the telescope. Which means using this, which I have now in my camera with my ZWO 294 camera, it's in the 8-inch Dobsonian, with this focal reducer in a certain position. I have it the closest as possible to the sensor, which means that what you see here, what you see here is 0.5. It means that it will double your field of view, more or less, but having it closer to the sensor, it will have less reduction. So when I bought this, I thought it was a flop, a bad buy that I made, and then I use it on the ZWO 224. On that camera works well because it has a small sensor, and with this camera you will see when I now connect the sharp cap, it will make loads of aberrations at the corners around all the image. Calv, welcome. Thank you. A 12-inch is amazing. Today I didn't place the 12-inch because I'm tired, and the 8-inch was faster. No, not yet, because it's I didn't try the Supernova because I was testing things, and with only just a few nights available, I'm centering on watching galaxies that I like a lot. I will now connect the equatorial platform. It's just to click in that button to turn on, and then you will see in real action, because you didn't figure what I'm going to do. This is a very, very nice trick, because it will make it will turn my f6 8-inch Dobsonian in a f4.4, a faster and very useful to use telescope. I'm opening Sharp Cap. Now, I will have to focus because this is with a reducer. You can see the stars. I will connect the platform. I will point to a bright star, any bright star in the sky, and then I will focus manually because my 8-inch Dobsonian is all manually. So it's time to start hopping. Okay. I love it. Let me just, for the people that enter now, hold on. Done. Now, important information, very important. For the 12-inch, I can use the focal reducer because I move the mirror up or to the front near the sensor, near the secondary mirror. And also I have a low profile focuser. It can work or not with our Dobsonian, 12-inch Dobsonian. But the good news for the 8-inch f6, you don't need the back focus. You have back focus. You just attach to the camera and you can turn the focus without problems. That's important information. Okay. Now, I think the focus is fair enough. You can see that also that with the 8-inch, the aberrations are not so evident, which is good. I almost could image like this, and it will have no problem. However, I will do the trick that I will show you now, and it's a thing that I will use for some objects.
Perdona, no lo tengo claro.
It was Alexa. I will not go deep in the matter. I will explain that carefully with a video. But I just want to say you something. This that I'm going to do has to do with oversampling or undersampling the image, the pixels. So what I'm doing with the focal reducer is adjusting the my pixel size according to the rule. And if you don't know, please study this on the internet. The between 1 and 2 arc second per pixel. Let me show you. I will not go deep into this today, but just for you to have an hint, there's loads of sites with this. I just search Google to show you. Attic cameras, this is the site of the cameras. Rules, between 1 and 2 arc second per pixel. I don't know if any one of you know this rule and how important it is for imaging and when to break them. Basically, I have a formula. This is a formula. When the image, usually my images are oversampled, the stars are bloated, like this one here, on the left, here, are oversampled, and at the right are undersampled. In a simple language, this without focal reducer and the Barlow, for example, with the height focal length, our telescopes tend to oversample. And then the opposite tends to transform the stars in blocky stars. If you can do the much we can in our hands to improve our imaging sessions, whether it's EAA or astrophotography. For astrophotography, this is super important. I'm shocked many people don't talk about this. I don't know. And if you can match your sky, because this depends also on seeing your sky with your telescope and your camera, you can have a better image. So let's see my fast and how I deal with the coma at the edges. Let me see if we can see. I will auto stretch the mini histogram to boost the image. This f6 have much less coma. If I place the 12-inch, it's much worse. You see the coma here? This star is stretched. Here, you see the star looks like a diamond or something like that. You see? All the edges, especially at the corners. You see here? This is the effect of the focal reducer. As I have it the closest to the sensor as possible, it's the camera, then the focal reducer, and only after the focal reducer I have the filter I always use, the Bader neodymium. The impact is not so strong. Now, if it was the 12-inch, it will be more stars around the center. Only the center will be good to watch, or comfortable at least. We don't want deformations. So let me just... So what I do is use the ROI, the region of interest. My camera, if you have the 294, you will have this capture area. I have 4,000 and something by 2,822. Okay, this is the maximum resolution of my camera. So now what I do to only have the good image without the coma at the edges, without the distortion, is to use a smaller capture area. After testing some, I choose this one, the 1000. It's 1900 and 1200, more or less. Okay. This reduced, as you can see, the star that was here, the bright star, it's out of focus. It's out of the screen, because basically what I did was this. You see this? This is the region of interest. This means that my camera right now is only using this area to collect the light. All of this around is not being used. Okay? Now, you can say, yes, but you can do the imaging session without this, with all the image, and then crop it at the end, and you get rid quickly of the aberrations. Yes, but in my case, that I have an equatorial platform which has poor tracking, it's an equatorial platform. Doing like this, I can do the imaging session, the EAA, only on the object I want, and then I can move, if the object is going away for some reason from the screen, I can move this using these little arrows here, the pan and the tilt. The pan and the tilt will move this rectangle up and down and left and right. You will see, because I'm going to do this right now. I will choose an object, or maybe if you want me, I have the Virgo constellation. I have already almost the Hercules cluster. It's the best view that I have now. If you want to choose a galaxy, and I point to that galaxy from the Virgo constellation, for example, we are on the galaxy season. We have loads of galaxies. Choose one, pick one, otherwise I pick myself. Too local. Focal reducer and field flattener are the same thing, right? Don't remember from top of my head. No, they are not the same thing. I recommend you, if you Google it, focal reducer versus field flattener, I'm sure there are loads of articles about that. They are not the same thing. For Newtonians, and of course Dobsonians, there is the best focal reducer is too expensive. It costs you about between $600, $700. It's too expensive. So it's a focal reducer. I think it's 0.75 or something, or 0.8, with comma corrector. It's a special focal reducer. Usually this is not recommended. Okay, M51. This is not recommended to Newtonians because of that issue that I talked to you. I said to you. But doing like this, we turn around that. We can use and revive something. I can revive something I had here almost dead. And actually, he gave me a very nice image, a brighter image because of the focal length. Remember, now I'm working on f4.4, not f6 anymore. So it's faster. The telescope, my 8-inch Dobsonian, it's faster. You don't see this too much. So it's a very, very interesting thing to show you today. Hello, salted wasabi. I don't use a go-to. Look, I use a push-to system, a free push-to system that I'm going to use now, you will see. And I have also exciting news if you use that system too, that I share with you. Because I tried that also with the barrel. And this is amazing because usually if you place a barlow, if it's not for planets, it's very hard to capture small planetary nebula or small objects with a barlow because you have a small field of view. But as it works with a barlow also, at least the 2x, I didn't try yet with the 4x. I doubt it works because it's too magnified. But with the 2x barlow, it will work fine. So you can use the push to my system of push to find objects without any problem. Sharp cap plate solved with a barrel and this camera. You aware that this is the 294. So let's hello team. How are you? I will open Stellarium. I will use now that push to. I have a video about it. If you want to learn, it's very nice because it's easy to use and it's free. We like free stuff in astronomy. Okay, I opened Stellarium. I have this configured to open already the telescope I have here, the brown, you see, the pointer, which is connected to. It opens immediately. I don't have to do nothing. When I click Stellarium, it opens now the pointer and this ASCOM that you have to install. It's just a little thing, the ASCOM simulator. Now, M51. Let's see where it is. I love this galaxy. I almost don't need for this galaxy. I watch it so much that I know more or less where it is. But this will help a lot. Now, what we're going to do is to slide this pointer over the galaxy. More or less, we can be just around and it works, which is amazing. The up, left, right, and down. Sometimes we click down, it goes up. It's a mess, but it doesn't matter. I will click down. You see, I click down, it goes up. You do the opposite. It doesn't matter the letters. Just matter that works. You see, look, it's there. I don't need to be closer. Now I will change for the camera sensor. This is my camera sensor. Not really, because my camera sensor now is cut. I have to configure here on SharpCap now that I use this feature a different size of rectangle to demonstrate to show me the real position of my camera. This is without the reducer, okay, and without me using the ROI, the region of interest. Now I will point the telescope. Pay attention, the ones that don't know this push-to system. I will go outside. I will point manually. I will do star hopping. I will point the telescope to more or less the place where it is the Whirlpool galaxy, and then I will click on SharpCap, and it will show me where my telescope is because he knows after I played solve, he will know where the telescope is. He doesn't know right now. Okay. So let's point. I will take this out. This is amazing. And I have more news, but for now, very nice news for the 18th Dobsonian owners. Very, very nice. Okay, I will point to the world. You see, the stars are big now, are larger or bigger than, because even that I'm using a reducer, I'm magnifying to compensate that. I'm magnifying with a region of interest, cutting the resolution of the camera. I'm magnifying, so it will more magnification than the reduction work. This is because I say this because of beginners. I said it's a bit for experienced guys, but if you pay attention to this, I will use this a lot. With $50, you can turn your 8-inch Dobsonian in a faster scope. Yes, you're right. Of course, there are reducers. There are loads of combinations, and I'm not an expert in optics, but I'm aware of those different combinations, and some very expensive, but very nice also. So this is just a cheap reducer, which it makes the things interesting. Now let's see. Let's plate solve. I just go here. You see this button here? Hold on. I want you to know, all of you. Let me just pick the pointer. Okay. This. You see this circle? You click and it's plate solving. Let's see what happens. It's not doing the job. I don't know why. Oh, I will cancel and do it again. That's never happened. This is working. Yes. No. Let's solve. Extracting sources. I don't know what is this. I made the upgrade of Shark app. I hope this. Oh, of course. I will use the largest resolution to find the galaxy. This is silly. Of course, you want to search for the galaxy. Look, it's there. Of course, you want to search for the galaxy with a higher resolution. This was a silly move by me. I'm very tired. You search, you do the star hopping with the camera in the larger resolution, and then I have to center. Now I will have to center the galaxy very well centered, because when it will cut, it will cut directly, because I have a sequencer to do the live stack already with that resolution. It will cut and the galaxy will be centered. Now, what I'm going to do is going outside to center the galaxy, and then let me just see if the plate solving works like this. Because this is something. Okay. We are always learning. You see, it plate solved. Now I go to here. You see, he's saying that my telescope is here, and right above at the right is whirlpool, and check that. Right, spot on. You see how it works very well. I was doing wrong. I have to plate solve with all the sensor. Makes sense. Now I will center manually the galaxy. You see the blue light? It's the light that I have here inside going to the telescope. I will explain what happened here. This is almost at zenith, and that way it's harder to point. Well, sequencer, I have a sequence for this resolution. I will do the 8 seconds. I can do the 10. The 10, okay. I will try the 10, it's not windy. And you will see. It will cut the sensor. You see the galaxy there? It's 2 up. What I'm going to do is going here. I know that I have to go up, so I click on the tilt down. I know more or less how many clicks I have to do. Now, what will happen is I will change from the stack here, down here, the stack view to individual frames. What I'm doing is watching the real image. I will clear. I don't need to clear. When I move the sensor, I don't need to clear, but I will now to start from the beginning. And it will keep the region of interest in the place I want. You see how good it is? Now, individual frames means that I'm watching the real image. The real image, the image that the telescope has, not the stack. I will change for stack, and I will do the auto color and then the auto stretch. Okay. This green is the light. This is over the position at north is not good for me. It's over the LED light. But it's like that. I will change it, the green. I will crank down the green. You see? And now I will wait for this to clean. Now, enhancement, bilateral filter, always the same. Let's see the full width half maximum filter. It's cutting 4 frames here. Now it catch. I have lowered the threshold here to reject frames below 5.5. Why? Because using the focal reducer, the stars will be sharper and smaller. So if I was using a Barlow, I had to crank up this threshold because the stars will be much larger. Now we will wait for this. You see, when the curve come from these lines, these waves come from the left and not from here, the bottom. This is because the light pollution I have. Now this is moving up, so I will do again the trick. I will move the ROI up. I still have a margin here that I can use while I'm stacking. This is why I don't crop it at the end. I prefer to do like this because I can manage more time the image. Yes, Antonio. I use the 294 camera. The plate solving is made by SharpCap. Look at the image is getting nicer. We have noise around, and we can see more noise because of the magnification of the field. But this will clean. And the image of the galaxy, it's much more detailed than not using the reducer. That's what I found. That was what I found. For now, I just test it with galaxies. I can't use this for large nebulae like the Lagoon Nebula, for example, that is large. Then in that situation, I will not use, or the Orion Nebula, I will not use this technique. This technique is wonderful. Look how sharp it's going, because it's faster. The telescope now is working much faster. Yes, this trick is very nice. You can use this trick without a reducer also. But especially you have an equatorial platform. If you have the same problem as I have, you see that it's cutting here because it's moving. When I point north, the platform have errors of speed, up and down. It looks really nice, yes. Now I will adjust the colors. Yes, I'm using darks. I took darks for this resolution, for this gain. I just cover the camera like this. No, I stopped the imaging and then I cover the camera and took darks, and now I use always that darks, those darks. Let me see the filter. It's rejecting some frames. This is wonderful, this nebula, this galaxy. You see the colors here? We have to adjust again. You see the waves, the curves are not aligned. I can do it manually. I can do the autocolor first. No, the autocolor was worse. I have to do it manually. Lower the green, crank up the blue, lower the green, the red is fine, and done. You see? We want to have this like this. And now we will slide this. See where it is? And let's see this one. Controlling the frames. And let's see. at 10 seconds. Okay. One thing you can do in SharpCap is, it's a little thing that is useful that I discovered recently, is you can, is silly also. You can push up the things that you want. You can slide it, you click and then you grab it, you see? Like this, up and down on the menu. So you can place down the things that you don't use, and you can place up on the screen the things that you use the most. Let me see. Okay. Instagram. And you can see that as it is faster, the telescope, it's at, I remember if you're getting right now at the live stream, my f6, 8-inch f6, it's working at f4.4. It's much faster to collecting the light. Being much faster is also much faster to focus and to find the objects. I like very much this discovery. I will use it now. I will use only Barlow's to planets and that stuff. I have to try this in a planetary nebula. I didn't try it yet. I had no time, no weather. But you can see that it's getting beautiful. Beautiful. And look how fine is the detail of the dust here. You see around the small galaxy, the interacting galaxy. I will make a video about this with the steps to use, and I will also make a video about some issues I had with this 8-inch, and I bet most of the people have also these kind of problems. I will show in the video. I had the vignetting, the focuser was not well aligned. I have to realign the focus from the origin. And also I had light leaks also. I solved those light leaks in the 12-inch, but in the other day I point a flashlight and loads of light here at the corner, upper left corner. So I solved that in a simple solution, and now we can see. And also if I was with the maximum resolution, it will vignette. The 294 camera it's normal that to have a bit of vignetting at the borders here. It makes a circle that we can mask with SharpCap in a certain way. But if your focuser is not well aligned, that vignetting will be shift, and that was what happened to me. Yes, I'm using right now. I'm using darks. I always use darks. It's a simple thing to do. You do it once from 6 months to 6 months. I usually change the darks, the dark library. I just make darks for the exposure times that I use. 4 seconds, 8 seconds, 10 seconds, sometimes 12, and that's it. And then I save it I keep it for about a season. For example, now I did it again, also because it's starting to warm up the weather. So warming up the temperature, I don't have exactly the temperature that many people have. Different darks for all different degrees of temperature. I don't have that. I think I don't need. I need to be close. I don't want to make loads of darks. But if you, for example, I'm using now The temperature of the camera is, let me see. This is interesting to know. I'm not using the cooler. Only. Where is the temperature? Camera controls here. 19 degrees. You see, it's not. I use the cooler, the mini cooler I have, that I made only in the hot summer nights. And the darks I'm using are, my god, for 26.7. It was too hot the some nights ago when I did this, but I have 419, I think. Let me see. I shouldn't use those 26 degrees Celsius. I should use, this is for 24, this is for 25. I have to I don't need to do more darks. I have here, no, this is not to use with the focal reducer. I have to do darks for the hot weather, not the winter is gone already. The gain, I always use the same gain. I tried this, I always use 350. It's the gain that works better for me with a regular using of the camera. As I'm doing like this, I have to, this is cutting to the left. I have to change here in the region of interest and go to the left a lot. Otherwise it will cut the galaxy. Let me see now. Let me see first where is the galaxy. I go to view, individual frames. Now it's centered. You see I can move it a bit up, yes, a bit up. I'm controlling this, it's funny also to do this while we are live stacking, watching the object. I moved up here, and now what I want is to match the stacking image to the real position of the image. You see, it's here, the dot, the core of the galaxy, and the stack, it's here. I have to push it a bit more up. I'm almost without space to go up. But you see, like this I can manage the position. The gain, I test different gains with this camera with a focal reducer working at f4.4. But the better result was the same, 350. So I kept the darks, I made the darks for 350 of gain and different exposures. The darks are essential for me because they help to get rid of the noise. Although I have here some dots you can't see probably, but I have here some blue dots and white and red dots, small ones, probably because I'm not using the right file. Yes, Tim. Only with the focal reducer and then the Bader neodymium over it, and it's over the LED light. I'm working. I am Bortle 5, but probably I'm Bortle 6 doing this galaxy. Although it's higher in the sky, it's almost at zenith, so it allow me to work better. If it was lower in the sky, I couldn't have the image like this so good. You're welcome, Ray. You know what I am here for, to share this and my joy with this, and also the information. To work, I like to work with what we have. I had that reducer, a ship reducer, and I thought it's a ship reducer, even that someone don't have the reducer. Many people asked me many time ago, should I buy a focal reducer? And I said, well, this the Coleman. But now, if you want to do this, it's good to have a focal reducer. Look what it did to the Galaxy. You will notice the difference because the details. Look at this. You see those the dust lanes here, so enhanced, and here this dust around, this spreaded dust around the small galaxy. I'm not saying without the focal reducer I couldn't have this, but I made the test and the comparison, and with the focal reducer, because of that rule of arc second per pixel, I thought maybe I can benefit from this rule, and yes, I can. I'm benefiting. I did the test, and also with the Barlow. I did a comparison also with the Barlow. I may do a video about it. I may place that in the video. The Barlow without reducer and the reducer. I record it. See the core and all those details on the arms of this beautiful galaxy. So we have already 11 minutes. I usually do about 50 minutes or so, because 10 seconds after 10 seconds the image is getting more and more and more. We having already dust lanes here at the top of the nebula. You will see after this the snapshot, and then with topaz denoise, one click and you will see how clean it changed the image, how clean it will be without this small noise that we can still see. Let me check the histogram. I will have to change the colors again, because the green when is light pollution, the green tends to, with this software and this camera. And that's enough now, because this is running away. I will push up the region of interest. The rest I can't go more than this. And left, it's the position that is changing. Let me check again. It's down here, and the stack, it's here. It's okay. Now I will crop the rotation and these platform errors. We have 12 minutes and a half. I will save as scene. Let me just do the color adjustment once more to make sure this is fine. I think it is. I will save as scene. I should have done this already, because I had luck not having a satellite photobombing the image. I will take a bit of red. Okay, save as scene again. And now, even while this is stacking, I go to topaz denoise. This is the only thing I do. I don't like to change colors, stuff. I like the realistic image. And let me see. And I will open the image. usually, you see, cleaning the noise. I would love it that SharkCap could do this while we are stacking. So I choose this one. She's beautiful. See, I save it. Where it is save, and that's it. And that's it. And now I crop it. I could crop it before. Usually is best thing to do. Crop it before applying. Now I will crop it. It's saved on the same folder. And here it is. Now I crop it. This, like this, to cut all the deformations. Save. That's it. A beautiful image. A beautiful image in 12 minutes of this galaxy. Do you think that it even get better with a 0.63 reducer? In the 12-inch, yes. I'm talking about only the ratio of reduction, the level of reduction, not the quality of the reducer. In the 12-inch, yes. I would change my chip 50.5 the reducer for a .63 or even a 75 or even an 80, because that will allow me to have less reduction. But if you are thinking the same thing that I did, which was to use the Celestron for the Schmidt-Cassegrain telescopes, to use that Celestron or other the Antares or other, I think is okay. The other reducers people use on the Schmidt-Cassegrains. There's a problem. That reducer, or those reducers, are fat, so you're not allowed to do what I do with this one. This one has 2-inch, an M48 thread that you attach to any camera filter or whatever, and then you place it all inside the folder, all inside the focuser. With that largest reducer, the camera will not enter because will not enter the reducer in the focuser. That means you will need more back focus. So that could be a problem also. I don't know because I didn't try it yet. I would love to try that. I'm so curious to know that. But I didn't try it. I don't have one, and thank you. Live stacking. It's still live stacking. Oh, it's ignoring. This should be already out of frame. No, it's not, but it will be. With an equatorial platform, we can do these things, but we are limited in time. although I don't want to be spend more time watching this galaxy, I want to watch another one. Do you want to watch another one? Want to choose one to finish this, or should I choose? Or should we finish here? And then I do another live stream again other day. It's better. I'm so tired today. Now, you learned today this wonderful feature of the focal reducer. If you have a focal reducer at home, you can use it doing this trick, and you will not have any coma at all, as you could see in the image. I hope you had a very enjoyable time here, and thank you very much. We'll see you the next live stream. I hope soon, when the weather allow. I will do again a live stream. Okay? What? With my Skywatch. The reducer, Galv. The reducer is not necessary. I use the reducer to improve it. You should use the formula. I will do this in a video. You should use the formula for the one. You search Google and study this before. One, you write on Google 1, 2 arcsec per pixel, and loads of articles from companies. You will find loads of articles explaining what it is and what it is for, and then they give you a simple formula. It's very simple. You place only the pixel size. You have to search the pixel size of your camera, the aperture of your telescope, and the focal length, and use that formula with the number they have to multiply, and the number it will give, you compare that in the table they will show, and you will see if you are undersampled or oversampled. And this will help. It's not needed, but it will help to improve your images. Okay. Oh, I'm tired. Ray, I will have to try it. Yes, try it. I will do more live streams with the weather now getting better. I will do more live streams. Don't worry, and we can share those. And I hope you try things that can share with me also, and we can try things here. Okay. Thank you very much, and see you on Friday in my next video, and hopefully in the next live stream. Okay. Bye bye.